on storage classes in C. Myself, Miss Priyanka Madanlal Channapattan, working as assistant professor in Computer Science and Engineering Department at Walchand Institute of Technology, Solapur. Now, let us see the learning outcome. At the end of this session, student will be able to identify the differences between automatic and register variable in terms of scope, lifetime, and initialization. Apply automatic and register variable effectively in the programming to control the data visibility and sharing. Next, we will see storage class in C. In the C programming language, storage classes are used to describe the feature of the variable or function. These features include the scope, visibility, and lifetime of a variable. In the simpler term, storage classes help us to understand where a variable can be used, who can use it, and how long it will last in the program. A variable storage class tells us where the variable is stored, what will be the initial value of the variable. If the initial value is not specially assigned, that is the default initial value. What is the scope of the variable? That is in which function the value of a variable would be available. What is the life of the variable? That is how long would the variable exist. Next, we will see key characteristic of storage classes in C. The first characteristic is scope. Scope defines where a variable can be accessed in the program. For example, the local variables are used only within a specific function and global variables can be accessed from any part of the program. Second characteristic is lifetime. The lifetime specifies how long a variable exists in the memory during program execution. For example, temporary variable in the function that cease to exist after the function ends, and persistent variable that retain value across function calls. The third characteristic is visibility. The visibility determines whether a variable is visible throughout the program or limited to a specific block. For example, external variables are used for global access across the multiple files, and variables are restricted to a single file for modularity and security. The fourth characteristic is memory location. The memory location specifies where the variable is stored, for example, RAM, CPU, register. The high speed CPU register are used for frequently accessed variable, and standard RAM allocation is used for regular variables. These are the key characteristics of storage classes in C. Next, we will see types of the storage classes in C. There are four types of storage classes in C language. First is automatic storage class. The auto storage class is used for temporary local variables. The second is register storage class. The register storage class is used for high speed variable stored in the CPU register. The third is static storage class. The static storage class used for persistent local and global variable. And fourth is the external storage class. The external storage class is used for sharing global variable across multiple files. Each storage class serving a specific purpose in memory management and data accessibility. In this video lecture, we will discuss first two types of storage classes in detail. Next, we will see automatic storage class in detail. The first type of storage class is automatic storage class. All variables declared within a function or block will be stored in an auto specifier by default, even if it is not explicitly defined. For example, if we declare int a is same as auto int a, automatic variable can be declared using the keyword auto. The scope or visibility of the variables in the automatic storage class is local to the block or function it is defined. The variable will be destroyed once we come out of from the function or the block. The automatic variable is stored in a memory. The default value of automatic variable is garbage value. The automatic storage class can be explained better with an example. In this example, a variable I of a type integer is declared first with the value 10 assigned to it. Next, inside a loop again, a variable I of the same integer type is declared with a value 20 assigned to it. If the storage specifier is not mentioned, by default it will taken as a 2. The first printf statement mentioned inside the block will print 20 on printing the value of I. Whereas in the second printf statement, which is mentioned outside the block, will print the value of I as 10, the value which is mentioned outside the block. It is better to initial some value to the auto variable because there are chances of getting any garbage value sometimes if initialization is not done. This example gives a clear picture of auto variables and about local scope. The output of the program is 20 and 10. Next, we will see second type of storage class, that is register storage class in detail. The second type is register storage class. The variable stored in the register storage class will be have local scope, which means it is accessible or visible only in the block in which it is declared. This storage class is similar to the auto, but the main difference is that the auto variable are stored in a memory, whereas the register variable are stored in the CPU registers. This is done if we want to access the variable very frequently. This can be used faster. Only a few variables are stored using register specifier. If there is no space in the register, then it is stored in the memory only. Mostly, length of the register are 2 bytes, so we cannot store a value greater than its size. If it is so, it will convert to automatic variable. Register variable can be declared using the keyword register. No initial value is assigned to a register variable. Then default value is the garbage value. Also, address of operator cannot be used on the register variable. For example, variable which are used for counters or similar usage type are stored using register specifier. Register variable can be declared as register int a. The register storage class can be explained better with an example. In this example, the variable a is declared as a register variable. Register variables are stored in a CPU register and do not have a memory address accessible via pointers. Taking the address of a register variable is not allowed, leading to a compilation error. The output of the program is compilation error. Next, we will see think and write question. Question is, can a register variable be accessed using pointer? Pause a video and write your answer. The answer is no. Register storage class in a C variable cannot be accessed using pointers because they are stored in a CPU register, not in a memory with a valid address. These are the references. Thank you.